Okay, guys. So I found out what the error was. So apparently I had another NeoVim instance running in the background, and that's what uh gave me the error. So nothing's wrong with the code actually. So yeah, let's go back to the code. Okay, so over here I have this delete from tail function. Uh, so I'll go through this again. So uh let's execute this function and see how it's gonna go. So over here we let's call it uh developing the linked list. So in these ones, okay, I create the linked list. So I add from head in these three instances. I add from tail, and then I add from a position as well. And then I traverse the linked list to see whether it's created properly. Then I delete the first value in the linked list. Then I traverse to see whether that first value was deleted properly. And then I delete it from tail. And then I traverse again to see the last value got deleted properly. So delete from tail removes the last value. Okay, so let's save. And then let's compile. See how it's gonna go. Okay. Then let's execute. Okay, here we go. So the first one shows us the entire list we created. So we added these values. So they got added from head. So we added 45, after that 89, after that 334. Then from tail I added 100 and 4542. Then from position I added 500 to the third index where it's zero based indexing. That means the fourth position. After that I deleted from head, which means I removed the first value. So this is the linked list we created. I removed the first value, which is 334. And then from that, I removed the last value, 45, 42. And then we are left with this one. So both delete from head and delete from tail functions are working. So if I go down, delete from head, over here we had delete from tail. So this is the delete from tail function. Okay. Delete from tail. Okay, so this is so let's go through the code again quickly. Over here in this if statement, I check whether the linked list is empty or not. If it's empty, then there's nothing we can do. So I give an error message, then stops the function from executing any further. And then I go to here. So what I'm trying to do is, so let's say over here in my right side in the whiteboard, this is the linked list we are dealing with. And I want to delete this last node. So technically I need to go to the node before the last node. So I start from head and then I jump through each node until I arrive to my destination. So one might can ask a question, why don't we keep track of tail and then go back? But that's not possible because each node doesn't know where it came from. So it doesn't track its previous node. That's a double linked list. In double linked list, you track both the node that comes after you and the node that was before you. In a single linked list, you only track the node that comes after you. So the tail doesn't know where the node before the last node exists. Only this node knows where this node exists. So because of that, we have to start from head and jump until we find the node we are interested in. So in this situation, we are interested in uh, the node that was before the last one, and we find it by checking uh, whether the next value of the next value. So temp next is equal null or not. If it is equal null, that means we have arrived in our destination. We have arrived to this node. So after that, we free temp next. Temp next is last node because we are in the node before the last node. Temp next is the last node. After that, we set temp next to be null. That's all. Okay, so that's delete from tail. So delete from head here. So delete it. Okay. So that let's go up now. Let's see what the functions we did. So we did delete from head, and then we also did delete from tail. All right. So there's another thing we need to do. We need to search. Okay, we need to be able to search for an element. I forgot to include it when I created this list before. Okay, we need to add that as well. So let's delete from a given position. Okay, like the last one. Uh, let's say that it's zero based indexing. So if I wanted to delete the fourth node in the linked list, I need to pass the value 3 because zero based indexing. Sir can give the question whatever the way he likes. He might give it as one based indexing as well. Like so, the first element's index is 1 instead of 0. So understand the logic here rather than trying to memorize the code because you can get the code in quite several ways, not just one. Okay, so let's go down. Delete from tail. Let's create one over here. Was it deleted position or delete from position? I need to create this function prototype. So let's call it delete at position. And what I need to pass the memory address of head pointer and also the position I need to get rid of. Then okay, let's call it head P and then let's call it position. Okay, again 0 based indexing. We need to check whether the function, the linked list is empty or not. Okay, so this is what it does again. So now what we need to do is that we need to jump through this linked list until we find the position we need to delete. Okay, so over here, let's get a struct node temp, and then let's assign head to it as well, so it's easier. Memory address of head p, and then I create for loop, and then I keep jumping until what I is post one minus post, and it should be null as well. Temp. If temp is null, that means we have come to the end of the linked list. Okay, so let's see the linked list. Right. Okay. Okay. So what we're doing here? We create an integer, initialize the value 0 to it, and then let's say that I want to delete this one. So this is the sorry. Let's go with this one because we have a larger number. So this one, this node over here. Look at the whiteboard. Okay, this one. So this is the fourth node. The index is 3, but we need to go to this one because that's how we can delete the one that comes after it. So we need to go to this one. Okay, so its index is going to be this less than 1. So that's what we are doing. We go up until that one, and we also need to make sure that the position isn't greater than the number of nodes we have on the linked list. So if it's the value is null, that means we have arrived in to the end. All right. So what I'm going to do, I'm going to check whether temp is null. If temp is null, that means we have come to the uh, end of the linked list. So what I can say is which error message did I give over here? Oh yeah, let's print this thing. Mhm. All right. So as I said, this is compile time concatenation. Just use small chat GPT. It will give you the idea what we are doing. It's not very complicated. Okay. So this is the exact same method I used when we created the header for our web server's response. All right. So if it is null, that means position is larger than the size of the linked list. If it's not, then I need to create another temp variable because now when I'm deleting this, what I have to say is uh, so I have to say the next value should be this one. So it should be pointing to this node now because and this node should be removed from the linked list. So what I need to say is temp means this one. Right now I'm here. Okay, I'm gonna give a T. I'm here right now. In this one. Okay, temp is this. So what I need to say is temp next should be this. This is the line I need to include. So what this is that the next value of this. So here, uh, next value of this node should be the next value of the node that comes after this. So this we're skipping this node. That's what we're saying here. That will initially delete this node from the linked list, but as I said before, this one will lead to a memory leak. So in order to avoid that memory leak, we need to remove this node as well. We need to free the allocated memory. All right. So in order to do that, we need to use free. The problem is, so if I say free temp next, so over here, if I come over here and if I say temp next, the problem is going to be if I remove this, then every node that comes after that also we are going to lose it. So if I call it after updating the next, so what I do right now is that I updated the next value of temp. Now it's pointing to this one. So this this one. The next is the memory address of the node that comes uh, after the next node. So if I say free temp next now, we will be removing this node. So it's a node we need in the linked list. So because of that, we need another variable. Let's call it temp2. Temp2. It's gonna be equal to temp next. All right. Then what I'm going to do is I can use uh what temp2 here as well. That's basically that's valid as well. And then I'm gonna free temp2. So yeah, and there's another thing. It might be good practice. Temp2 Next is should be null. I don't think this one won't be valid because we are free in that memory space anyway. But uh, yeah, it won't be necessary. But just in case if you like won't feel like you want to be extra safe, then it's uh, good practice to do because if we don't do that, then the two nodes are pointing to the same memory space. So I have this temp2. This one will be temp2. Okay, so I'm gonna give the value 2 here. Temp2. This one is temp2. And I'm gonna say temp next is temp2. And if I don't use this line, so in now what will happen is both temp and temp2 will be pointing to the same memory space. I will free this memory space, so the temp2 memory space. So there won't be an issue. But if you feel like you want to be extra safe, then that's something you can do. All right, so that's it. I'm not going to include this one. So I free temp2 and then update temp1. Sorry about that. Okay. Uh, so let's go up. hmm Okay. It's called delete from position. Delete at position, right? Delete at. And I want to remove the third value, so let's give the index 2. And let's traverse again. We have an error. Delete at position. Oh, right. I think I made a small error here, which was delete from tail, delete at position. This free new node one. We are creating a new node. I just copied the code, so that's why it was there. So let's compile again and see. Still got an error. Delete at position, warning, implicit declaration, delete position, at position. So obviously, oh yeah, think I mixed up capitalization. Yeah, over here we should be capital. No, still getting one. Oh yeah. So because I'm using I outside the loop, I should declare it over here. And we're good to go. Now let's execute and see. Okay. So here we go. Uh, so I think I should go to the main function so you guys can see what's happening. So yeah, let's leave it. Yeah, let's leave it like that. Okay, here we go. So I kept deleting. So this is the original linked list we created. And then I deleted from head. So the first value got removed. This one got removed, starting from 89 now. Then I deleted the last value, 45, 42. So it's now 89 and 100. Then I wanted to delete the value at the third position, which is the second index. So in this situation, it's 500. And now 500 is gone. We are left with 100. So if I want to remove 45, which is the second value, which is the first index, uh, index number 1. So if I want to remove that, what all I have to do is just replace it there and then compile. And now 45 is gone. Okay. So hopefully we won't have any memory leaks as well. There will be a memory leak because we aren't releasing the entire linked list once we're done dealing with the program. Okay, so if we take a look at what we have to do, So now we have finished insertion, deletion, and traverse. Then the next one we have to do is search, and then the reverse one. All right. There are two ways to reverse a linked list. There's normal way, and there's another method based on recursion. I'm not so sure whether Manjusa did that one or not. If he did it, then I will cover it after doing recursion. Okay, so I won't be covering recursion based reversing right now. Okay, so I will teach you guys how to reverse, but in a normal, the basic one. Okay, so now let's do the search. Search is quite simple. What we're going to do is uh, we are going to look for the value that was given by the user, and we are going to return the first index of the node that has that value. Search, okay, it's called search, and then we're going to pass the memory address of head, and then we're going to pass the value it needs to look for. Okay, and then it's called search. And then int, let's call it val, value, val, whatever, let's call it val, it's easy. So again, you need to check whether the linked list is empty or not. And then linked list is empty. If not, what we're going to do is we're gonna keep looking for the yeah. So let's get a for loop, and we're gonna within the for loop we're gonna keep looking for that value. Struct node temp is equal to the value of head p, and then I'm gonna go until the last one. Uh, okay, so struct node temp. So what I'm going to do is if val temp data is equal to the value that was passed by the user, I'm going to return I need to keep track of I as well. So yeah, one thing I can do is I can create an I integer like this over here. Okay, so I'm going to say 0. So yeah, there are two ways you can do that. There are two ways the previous functions this one can be done as well. Okay, I will show it after doing the simple one. Return uh, I plus plus. Okay. So yeah, what we're doing here, we created this temp variable of the data type struct node. It's a pointer. Point to it point into the first node. All right. So I mean, I'm gonna go up until we come to the last node, and then for when we are in each node, we are gonna check whether the value is uh value is equal to the value passed by the user, and then what we're going to do is that we are going to wait, yeah, if it is equal, then we are going to return that value, which will be the index of that node. Okay, we're going to return the index of the node. If it's not equal, then we are going to update it. So this one is quite similar to saying else and then putting this inside here. This is basically the same thing. I didn't do it because once you encounter the return statement, the function stops executing. So uh, if you go to I plus plus, that means that the value wasn't found. So that means that the condition was evaluated before. So you don't need to explicitly include that else part. But if you feel like that it's hard to understand, it's completely fine to include it. Okay. So here I increment the value of I. If the for loop finished executing without returning the value, that means that the value wasn't found. Then I'm going to return -1. That -1. That means the value wasn't found. So, found. Let's compile and see whether we had errors. Yes, we do. What is it? Oh yeah. Oh here. Because I say that this will return an integer value. I can't say just return. I have to return a value. Okay. So what's the other error? I'm missing a semicolon somewhere. Out here. Okay. Should be here actually. Yeah, that's pretty much it. So that's the problem actually. Once you have like this unnecessary if else statements, it's hard to keep track of all the curly brackets because there's a lot out there you have to keep track of. Okay, that's not to compile. It should compile it. Let's go here. Let's check the values. That's wow. See which values exist in our linked list so far. So we have 500, 189. So let's call the search function. And then I'm going to pass the memory address of head. And then I'm going to pass, let's say 100. And this one's going to return an integer. So let's call it position of 100. Let's call it post 100 so it's easy to understand. Then let's print the position. Printf position of 100 is, oops, expression was 100. Easy, let's see. Not sure. Let's compile and see. Okay, so the position of 100 is 2. So let's call it index so it's more clear. Easy to understand. Here we go. So as you can see, now this one's correct because index of 100 is 2, which is actually this one. 0, 1, 2. If I want to find the value of 500, what is it? Yeah. Why is it returning 2? Oh, I didn't change the value here. Here we go. So the index of 500 is 1. Here we go. So let's say that you want to what? You want to remove a value 500. So what you can do is that instead of giving the manual value here, what you can do is uh, call the search function, and I have to pass the head. Oh, I have to pass the memory address of head to search function, and then the value I want to return. Okay, and there should be another error handling implemented in this deleted position, that is to handle -1. At the moment, we aren't handling it. I'm not going to include that code, because if search returns -1, that means that the value we are trying to delete doesn't exist. So what I'm trying to do over here is that, so in the delete at position function, we need to give the index. So first of all, we need to know, actually we want to delete values from linked list, not the positions. Like we have a value that we don't want in the linked list, so we try to delete that. So but if you take a look at the deleted position function, it doesn't take the value, the it takes the position. So if you want to find the position, you have to use the search function. So search function, what we do is, we pass the value we want to find to the search function, and it returns the index. Then that index is passed to deleted position. So if it returns -1, that means that it wasn't found. That means there's nothing to delete. So I didn't implement that error handling into the deleted position function, because this isn't a program. Okay, but if you're writing a program, that's something you can do. So now what I'm doing is I'm deleting 500 from the list, so that it shouldn't exist anymore. Okay, so let's see what we're gonna get. Let's save first. Okay, we have an issue. Expect at 4853. Oh yeah, I'm missing a parenthesis. I didn't save. Now no compile time errors. Now what happens is that if you take a look at this, now we have this one, and then I call this deleted position function. Then the value 500 got deleted. And if I try to find the position of 500, it returns -1 because it doesn't exist. So if you want to include this in a program, what you have to do is deleted position. If you go to delete from tail and delete from position, so I have to check whether position is -1. That means that that value doesn't exist in the linked list. The position doesn't exist. It doesn't exist. So just print a message. Uh, invalid index. And then just stop executing the program. So you don't need to include this in your papers or any of the what is it? Any of the assignments you do. If you can include, it's absolutely no problem. It's not necessary. But if you feel like you should, then it's no problem. But this is a way you can handle that error. Okay, so that feels a little bit more like a complete program. All right, so we did the search. Search is quite easy. All you have to do is just go through the linked list. Okay, and then if you find the value, then yeah, I have to teach you guys how to do that, right? Yeah, okay, I will give you go. So as I said, yeah, what we are doing in the for loop is we are going through each node, check whether the value is equal to the value that was passed by the user. If it is, then we return the index. Otherwise, we return -1. So over here, I have two iterators. I have I and the temp. Okay, temp keeps track of all the nodes in the linked list. I keeps track of the index. Okay, so in this for loop, I have two iterators that keep getting updated. So this one's a little bit advanced, and if you feel like this one is not for you, then you can skip this, no problem. Okay, so instead of declaring I outside the loop, I can use it inside this brackets. So what I can do is I can create another iterate. No, sorry, I had to create the iterator here. So I have the iterator over here. So instead of updating I over here, okay, so, what I can do is Uh, I can update the IO. I can update IO here. No problem. So this one will also work. I can't include I in this part because the both temp and I has to be in the same i- from the same data type. But it's not in this case, so I can't use IO here. Just watch my follow video. You guys will have an idea. And then if I try to execute, I get the same error. I get the same result. Okay, so it's the same, basically the same thing. You can do it like this. Same thing over here. So if you take a look at what this search, delete that position, and over here, what I'm doing is I'm updating the temp inside the follow body. I don't have to. I can basically go here, put and do it like this. So it's basically the same thing. I am updating two values in the update section of the follow. Okay, if I compile, I get the same result. So this was delete that position, and the value 500 got deleted. So that's the one we passed in our main function, if you can remember. That's the position we passed. All right. So yeah, we have done all except reverse now. Okay. So in reverse, what you have to do is basically just reverse the links. Okay, so let's find an empty space. Okay, so we got empty space. So let's say, give me a moment. Okay. Uh, yeah. So we have a linked list like this. I'm gonna draw circles. Hopefully that's no problem. Okay. Okay. We have, so these are nodes. I'm not gonna draw squares because it's easier. Okay, so these are nodes. They are connected using links like this. All right. So in reversing, what you have to do is you have to reverse the these these links. So if you are reversing, they should be pointing to the other way. So this one should be pointing like this, and head shouldn't be here. Head should be pointing to this. Right. So that's reversing. So what you have to do is you can yeah, let's create the function prototype first. Then you're gonna pass the memory address of head. Uh, okay. So again, we need to check whether it's linked list is empty or not. Okay. Let's get this one up a little bit so it's easy to read. Okay, there we go. So how we do this is that if you take a look at a linked list, okay, so you have nodes like this. So let's have three nodes. So I'm going to, okay, so over here I'm going to have non-existing one. Okay, so can I draw dotted lines? Oh yeah, there you go. It's better if I might just work that way. Yeah, let's say that there's a node and another one here. This one doesn't exist. Okay, you guys will understand what I'm doing here. Give me a moment. Let me cook. Okay, this is it. So what we're going to do is we're going to have what? We're going to have a temp variable which will be pointing to this, and then I'm going to have a previous variable and a next variable. So what I'm going to do, this one will be null. Okay, because this doesn't exist, this one will be null. So at each temp, what I'm going to do is I'm going to say temp next is equal to null. By that, temp next is this. By saying that, I turn temp next into this. So it will be pointing to this one. All right. Then I'm going to say uh, temp equal. Give me a minute. Then I'm going to say temp equals next. That means I take temp to this one. Okay. Now before that, I have to update previous. Okay. So right now, previous value is over here. That now I updated this node. So now temp should move to this one. Next should move to let me use the temp is here right now. After finishing the update, temp should move to this node. Next should move to this node, and previous should be moved to this one. So what I'm going to say is I'm going to say previous equals current temp, and temp is going to be equal to current next, and next is going to be equal to you can use either temp next or next. Both basically point to the same memory space, and then again keep repeating this part. So then again I repeat this temp uh, next equals previous. That means I again point it to this, then again move. Right, let's give it a try. So I'm going to create three variables, three pointers of the node data type. Okay, so one is going to be previous, it's going to be null. Then I'm going to have a temp which will be pointed to the memory space of head. I haven't included that here. And should be comma. And then I'm going to have next. So it should be over here. Next. So the next is a variable. Okay, so over here we have a member called next as well. Don't confuse yourself. Okay, this one is a member of the node data type. Over here, next is a pointer. So they both have the same name, but they refer to two different things. Next is going to be next. So it's going to be pointed to the second element in the linked list at the beginning, and then we are going to start iterating. Okay, so over here we don't need an iterator. We can leave that empty because I included it over here, so I don't have to assign it again. All right. Then you guys can use a while loop as well. And it's completely fine, but for some reason I prefer to use for loops. All right. So what I'm going to say is, uh, I'm going to keep updating until uh, temp next not equal null. You guys will see why it's temp next instead of temp. And then for the update, there are three things I can do. Uh, let's do it inside the body, otherwise it will be really long. Okay, so what I should be saying is, in the update section, it should be temp should be next, and next should be next, or you can use temp next as well. So in the body, what I'm going to do is temp next is going to be pre. All right, so that's what I'm doing. You can include this part. Oh, it should be separated by a comma, not a colon. Right, temp previous equals temp equals next equals next. You don't have any compile time errors. So so the condition is temp next is equal null. That means we're here. If temp next is equal to null, that means we have come to the last node of the linked list, because that's the one where temp next is equal to null. So after executing the body, I have to say temp next should be previous value, and head sorry, value of head should be temp. Sorry, it should be temp. So if I say next, if not if I say temp is uh, if for the condition, if I say until temp is equal null, yeah, instead of temp next is equal null, so in that case temp will be null. So in this situation, okay, so over here, undo what I said. So over here I say temp until temp next is equal null, execute this for loop. So I use temp next instead of temp, because when we come to this situation, when we have come to the last node, temp isn't null, only temp next is equal to null, but next is null. Okay, so the next value will be null, previous will be pointed to this one, next will be null, and over here I have this update statement saying temp next equals next. So that's going to give me a segmentation fault. In order to avoid that, I have this. I start from here and then manually handle the last one. All right, let's give it a go and see how it's gonna work. Uh, reverse, and then it's traverse again. Okay, here we go. There we go. So we have this. So I'm not gonna go through this again. Okay. So this is the linked list. This is the original one we passed. So starting from 89, then 4500. After reversing, 100 comes first, 45, then 89. Okay. So if you want to like reverse the larger link, reverse the original linked list. So let's reverse that. So so let's reverse after creating the linked list. So that because there are a lot of elements, it will be easier to see the changes. Okay. No, I reverse before traversing. Okay, here we go. So I create the linked list using various methods. Then I traverse to see the original linked list. Then I reverse. Then I traverse again to see the effect of the reverse. Okay, here we go. So this is the original linked list. 335, 89, 45, 500, 100, 45, 42. After reversing, 45, 42 becomes the first one. Then 100, then 500, then 45, 89, 334. All right. So yeah. So after reversing, the first element becomes this one. And the first one we call after the first delete function we call is delete from head. So this one gets removed. So the 100 becomes the first element and so on. Okay, that's it for single linked list. Okay. So, and there are three other types of linked list. Manju didn't cover a lot, but he did tell what they're about. Okay. So this one is known as a single linked list. Okay, let's go through this quickly. Okay. Okay. So uh, over here, so what we did something like this. So the linked list we did look like this, where each node pointed to the node that comes after this. So this is a single linked list. Okay, and there's a something called double linked list. Okay, double linked list. In a double linked list, unlike a single linked list, a node keeps track of both the previous and the next node. So it's like this actually, you know, and then this one should be null and null. Okay, so I'm not gonna go through the code for these ones because all you have to do is update the linked list, single linked list to keep track of the uh, previous one and then update the code a little bit. So all you have to do is struct node prev. So that's all. So this is the only change you have to keep, only change you have to make. Okay, you guys can do this on your own, and if there's time, I will give you the code. Okay, so that's a double linked list. In double linked list, each node keeps track of both the next node and the previous node. And there's another one called circular linked list. Okay, in a circular linked list, so the tail points to the head. So so this is the head. So this is the linked list. So this is a traditional single linked list. Okay, so each node pointing to the node that comes after it. And in a circular linked list, the tail, the last linked list, last node of the linked list, points to the head instead of pointing to none. Okay, that's again very little change to the original code. And then the last one is known as double circular linked list. It's basically double linked list plus single linked list. So we have these several nodes like this. This one, let's call this the head. So like this, each node keeps track of both nodes that before and previous, and the last node points to the head, and head points to the tail. So that's the double linked list. Should be a D. Mhm. Wait, there we go. So this one should be just give me what I want. Thank you. So this one is a circular double, so you can call it circular double or double circular linked list. All right, there you go. So those are the four types of linked list we have. So we have uh, single linked list, double linked list, circular linked list, and double circular linked list. Uh, Manjusa just mentioned these three types of linked list, so don't no need to focus a lot on them. But it's a good, always a good idea to be familiar with them. So just in case. Okay. Right now I won't go through the code because all you have to do is like make some small changes. So my suggestion is that just play with this code a little bit. So like memorizing and studying it uh, only won't help. So you have to work with the code a little bit. So yeah, that's pretty much it. If you guys have trouble understanding the code, okay, so I do believe that this is a little bit advanced. So if you take a look at the for loops I created and everything, it's not what we are used to. Okay, so these for loops and stuff aren't. Uh, I do agree they are simple, but you guys have to get used to those because you don't know. Majusha taught these for loops without a body, so you don't know what type of code he will give in the exams and assignments. So you should be able to understand the code he gives as well, not just write your own code. So you guys, it's always a good idea to get used to this. So just in case if you get something like that, then you would be able to understand what's happening. So that's it. If you like find it's difficult to understand, then drop me a message. Drop me or Isum Ravindu or anyone a message, and I will try to find another way to fix that. But what I have to say is that you should be able to understand this because you don't know we don't know what we might get. Okay, so that's pretty much it for the link list. Uh, so yeah, after this I will be doing some algorithm analysis. And I will go through how to reverse a linked list using recursion after doing recursion. Won't be doing that right now. Apart from that, linked lists are complete. Okay, so that you guys should have an idea. Then I will give you a note on advantages and disadvantages of linked list and stuff like that as well. So to understand advantages and disadvantages, you need to have a little bit of an idea of algorithm analysis and big notation and stuff like that. All right. So that's it. Yeah, hope you guys come to hope to see you guys in the next copy. Have a great day. Bye.